10, height is 5. So now here 5. So work done W is equals to 25 joule. Work done W is equals to 25 joule. Next, a child standing at the center of the platform with folded hands. The platform is rotating about a vertical axis to a center. Child is standing at the center of the platform with folded hands. The platform is rotating about vertical axis to its center. The kinetic energy of system is K. The kinetic energy of system is K. K1 is equals to K. The child is now stretched his arms. So that moment of inertia gets doubled. So earlier moment of inertia I1I. Now moment of inertia gets doubled. So 2I. So now they are expecting kinetic energy of new system becomes. So whenever folded hands, touched hands, this is the concept of law of conservation of angular momentum. So L is equals to I omega. L is equals to I omega. So this is kinetic energy versus momentum. Kinetic energy Ke is equals to L square by 2I, because this is the concept, remember, regarding law of conservation of angular momentum. Angular momentum remains constant. So Ke proportional to 1 by I. K1 by K2 is equals to, we have I2 by I1. So K1 is K, K2 need to calculate. I1, I2 is I1 this is. So now K2 is equals to K by 2. Kinetic energy is halved. Kinetic energy is halved. Next, one more question. U-shaped, this is U-shaped tube has water and mercury. U-shaped tube has water and mercury. This is a U-shaped tube which has water and mercury. Like this they are given, which is water and mercury. So here, so water is at a height h. This is the water. U-shaped tube has water. This is the given diagram. So now this is only mercury. This is only mercury. Mercury is at 5 centimeter height. Mercury is at 5 centimeter height. So what about the height in the liquid column? This they are asking. Height. So in the given, the height of the mercury column is given. Height of the mercury H mercury is equals to 5 centimeter. So they are asking height of the water column. H water they are asking. So here density of water they provided. Also we don't know. We know 1 gram per cc. Density of mercury they provided. Even they won't provide also we know 13.6 gram per cc. So now we need to calculate mercury level of the height in water column. So according to force of Buoyancy, F is equals to mg. So now here both are liquid, remains constant. So now F is equals to rho b VBZ. Rho b VBZ is equals to rho mercury. So rho L VLG. But they are given both are liquids. That's why we have to calculate it. What's that? Here volume is we can write in terms of area into height. Volume is equals to area into height. Both areas are same. So rho 1 is mercury, rho Hg, HHg into G is equals to rho, this is water, rho W, HW and G, because area is same for both. GG cancel. So now here we have 13.6. This is H, mercury is 5. This is rho water is 1. H water we need to calculate. H water is equals to 68 centimeter. Next. A water tank has height 10 centimeter, completely filled with water placed on the level ground. Water tank of height 10 meter. Water tank of height 10 meter. Water tank of height 10 meter. So here completely filled with water placed on the level ground. It has two holes, one at 3 meter, other at 7 meter from the base. So this is a water tank. So water tank of height. This water tank of height. This water tank of height they are given h meter. This is total height is h meter, 10 meter. So but they mention, so it has two holes, 3 meter and 7 meter. 3 meter and 7 meter from the base. This is 3 meter from the base, one hole. So it is coming like this. This is 3 meter height. So and another one is 7 meter height. This is a hole, 7 meter height. 7 meter height. So this is hole. So they are mentioned water ejecting from. Generally total height is 10 meter. This is 7 meter, this is 3 meter. So both will reach the ground at same time and they will cover same distance range. So ranges R1 is equals to R2 is equals to R same. R1 is equals to R2 is equals to same. So generally we have to find range. Range is equals to velocity into time. So velocity is here. Velocity here is V1 into T1. First hole. R2 is equals to V2 into T2. Second one. V1 is first one is root 2GH. T1 is time taken is root over 2 capital H minus small h into G. This is. And R2 is equals to V2. V2 is equals to root over 2 H minus H into T2 value. Here we have T2 value. T2 value is root over 2H by Z. 2H by Z. If you observe that both ranges are same. Because this is small h, this is capital H minus H. This is small h, this is capital H minus H. So R1 is equals to R2. Range is same for both the objects. So among the following. So ranges are same. Next, two spheres made same substance have the diameter in the ratio. Two spheres made same substance, diameter in the ratio. Ratio of diameters is 1:2. Thermal capacities ratio. Thermal capacity C1 C2 ratio. So generally diameters given, diameter ratio and radius ratio both are same. Ratio of diameters, ratio of radius both are same. So C is equals to, we have dq by dt, specific heat capacity dq by dt. So here we have density in terms of C is equals to, specific heat is not mentioned, S is equals to 1 by m dq by dt, 1 by m dq by dt. So this is equation 1, this is equation 2. So now we have to calculate S is equals to 1 by m into C. So C is equals to EMS. C is equals to EMS. So now C is equals to M means mass is equals to density into volume into S. So both the spheres have same heat capacity, So now here rho 1 by rho 2, volume is radius ratio given 4 by 3 pi r cube, R1 by R2. So C is equals to rho 4 by 3 pi r cube S. 4 by 3 pi r cube S. So rho constant, S constant. So S1 by S2. So C1 by C2 is equals to R1 by R2 whole cube. So C1 by C2 is equals to 1:8. Next, two balls are projected upward simultaneously with the speed 40 meter per second, 60 meter per second. Two balls are projected simultaneously upward with speeds 40 meter per second and another one is 60 centimeter per second. So relative position x of second ball, relative position of x of second ball, relative position of x of second ball second ball, with respect to first ball, at t is equals to 5 second, this is x is relative position, we need to calculate relative position. So mention neglect air resistance, so we have to calculate relative position. Generally S is equals to ut plus half at square, because u given t given, so S relative we need to calculate. This is u relative into t plus half a relative into t square, So now u relative is u1 minus u2, u relative is u1 minus v2. So velocity of one object with respect to the another object, so height u2 minus u1, like that. So 60 minus 40, that is 20 meter per second. So acceleration relative, they are giving neglect air resistance, both are projected simultaneously upwards. So acceleration relative is 0, because they are moving what? In a straight line path. So now S is equals to, S relative is equals to, that is x, u relative value 20 into t value 5 second, this is already 0 of a relative is 0 into t square. So relative position is 100 meter.